Good afternoon to everyone. My name is Mario Solaro, and my presentation is called Information Integration in Heterogeneous Data Warehouses. So the main motivation of my work is small and medium enterprises that usually lack resources to pursue new business markets and to reorganize whenever the situation may require it. For example, during the financial crisis, many markets have shrunk or have disappeared. So usually small and medium companies that don't have resources to reorganize themselves and place themselves to another markets usually have difficulties to remain competitive. For example, big companies usually have assets and resources to invest in research and to risk assets in new business opportunities and new economical markets. That is why recently managers realized that small and medium enterprises may obtain a competitive advantage if they pursue a collaborative approach rather than a competitive one. Okay, so traditionally, companies that operate in the same sector have had a competitive approach to business making. They were competitors, but recently, as I told you, they realized that they can be even more competitive if they try to collaborate among themselves. Okay. So business collaboration has been defined recently, although it has been around for a while in business structures like supply chains. But recently there have been these new business structure proposed, like the Federation of Companies and also the virtual enterprises. One of the main problems in collaborating businesses is that usually business people lack information systems that can facilitate the collaboration among enterprises. One of the main issues is that managers on top of business network must be able to take decisions based on information coming from all the companies and for the benefit of all the participants. Usually when we are talking about decision making, we are talking about strategic information that is usually obtained and derived from operational data, and it is stored in data warehouses. If we are talking about information coming from multiple data warehouses, of course we have some issues like schema and instance inconsistencies. Okay, we may have the same information, but because it is structured differently, it may appear different, or it may have even different interpretation. So one big issue is that until now there has been no complete automatic data warehouse integration methodology to support the integration of information for collaborative enterprises. My contribution, I would like to develop a complete heterogeneous data warehouse integration methodology that is able to automate this integration process. Okay. Until now, I have been able to completely formalize the dimension integration methodology. Usually data warehouses are structured using facts that are analyzed using measures alongside the dimension of analysis. The method that I'm trying to propose is similar to classical data integration. It uses semantic mappings to express semantic similarities among similar or related concepts. Then the semantic mappings are used to write a query locally. Also, the query is forwarded to the other nodes, and it is rewritten using the semantic mappings on the remote compatible schemas. Then the information obtained locally is integrated with information obtained from the remote instances, and then a unified view is presented to the final user. So I'm using semantic mappings among different dimensional attributes. So what I basically do is I simply consider dimension as direct labeled graphs, where the label of each edge is the so-called cardinality ratio among different aggregation levels. So for example, if we have two concepts and one is an aggregation of the other, the cardinality ratio is simply the average number of different values from the lower aggregation level that corresponds to every single value to the higher aggregation level. Then what I do is I use some graph theory to extract. So suppose that those are the two initial dimensions. I use graph theory to extract a common subgraph from the two initial graphs that I then use to identify similar attributes from the two initial graphs. Then I use a set of 5 inference rules to generate semantic mappings among each two pairs of attributes from the two dimensions. Okay, so one may know, first of all, I have done also some experimental results. I have done some experimental evaluation of the mapping discovery method. These are some data that I have obtained. And the main result is that although the information may be different, although the information contained in the different instance may be different, for example, here I analyzed the instance of the same dimensions, and there was an overlapping of 16%. The structure of the dimensions was roughly the same by an error of no more than 12%. This is basically happens because although we may have different information, usually people tend to structure it in the same way because of the way the structure is the concept is structured in the common knowledge. For example, if you think about it, different people will tend to structure a time dimension in the same way. For example, we have days that are grouped into weeks. Days are also grouped into months, that are grouped into semesters, and that are grouped in years, and so on. So if you have different groups and you ask them to model a time dimension, they will basically model it in the same way. Okay, so we have discovered the semantic mappings. For some people, this may be enough, but in classical data integration, this would be sufficient, but not in information integration. This is because usually managers in a business network must have the same overview of the entire available information. But if you write a query and you forward it to more schemas, you have the problem that the expressiveness of the query is limited by the compatibility of the schema, because you write a query, you execute it locally, and then you forward it to compatible nodes. But there may be the case that the query is compatible with all the nodes in the network, it is compatible to only a subset of the network, or it is compatible only to the local node. So here one may use several strategies. For example, you may allow the execution of queries that are compatible with all the nodes, but this means greatly limiting the interrogation capabilities. Furthermore, you may forward the query as is. You may inform or may not inform the user, but you see that the big problem is that this creates a lot of confusion for end users. My solution is that we can use the semantic mappings discovered in step 1 to uniform the dimension by importing remote compatible dimension levels. For example, if you imagine to have two dimensions, this one and this other one, in the first you have two-dimensional attributes, city that roll-ups to country, and in the other one, city roll-ups to province, and province roll-up to state. Now, if from step 1 we have discovered that city is equivalent to city and country is equivalent to state, well, you somehow imagine that these dimensional attributes would fit right in here. So what I do is I do exactly this operation, but rather than inserting it directly here, I create an alternative path because this attribute is optional, because there may be the case that not every city has a province specified. So in the end, if I'm able to find a province for every city in the instance of this schema, then I promote this attribute to mandatory attribute. Also, the dimension levels that are important maintaining coherency, which is a property defined for data warehouse dimension. After that, after having imported the dimensional attribute, I have to populate it with consistent dimension values. So in this case, I have been using two approaches. First of all, I have studied the use of this procedure defined in literature for reasoning about the dependencies on the databases and dimensions. This is an exact approach, but later I tried to apply the relevant clustering technique that was developed inside the MOMIS data integration project, and this is an approximate approach that is better than the dimension chase because it is able to detect similar but not identical values that would, an exact approach would seem different. For example, if you have the name of the same city in two languages, for example, Turin and Torino, an exact approach would find the two values different, while clustering technique will find that the two values correspond to the same concept. Also, the relevant approach it's able to detect and fix wrong or missing values. In conclusions, the two main conclusions that I can draw from my work is that data warehouse integration, although may be seen as a case of data integration, it is a context-specific methodology where analysts may use the knowledge that they have about the structure of the schema, which is the multidimensionality. Also, it is possible to combine various approaches to increase accuracy. For example, in the first step, the mapping discovery step, I have been studying the combination of structural properties and semantics, and I found out that a combination of the approach is usually more accurate. Also, as a future work, I would like to refine the mapping discovery step to make it even more efficient. One important study in my PhD, I think, will be the study of formal properties of the mapped schemas. And also one important topic will be the study of the summarizability of measures to handle information overlapping. Because as it is now, this method is based on the strong assumption that the facts are not overlapping. We were talking about different data. Okay, so this is a list of my publications. Thank you.
So thanks for your presentation. Any question? Okay, thank you. We have again the last two presentations. The first one will be given by Marcello Pietri.